This problem gives us a graph of a function v of t, and we need to interpret it in order to answer the questions. Let's start with number 1. In number 1, it says at t equals 4 seconds is the particle moving to the right or left. The way we tell direction of movement is by the sign of velocity. So we can see, by looking at the graph, that at t equals 4 seconds, which is happening right here, we can see that the sign of velocity is positive. So v of 4 is greater than 0. We see in the description up here that this is a velocity of a particle moving along the x-axis. So if the velocity is positive, this means then that the particle is moving to the right. Number 2, it asks us over what time interval the particle is moving to the left. The particle is going to be moving to the left then whenever the velocity function is negative. And we can see that this happens during this portion of the graph right here. So this means that this is going to occur when t is greater than 5 and less than 9. Notice that I'm not including 5 in this interval because at t equals 5, the particle has 0 velocity, so we wouldn't say that it's moving in either direction. For number 3, it asks us about acceleration. We know that acceleration is the derivative of velocity. So we can look at the velocity graph here and find its rate of change, that is, its slope, by looking at the graph. And so we can see that at t equals 4 seconds, v prime of 4, which is going to be the acceleration at time t equals 4, looking at the graph, we can see that the slope is negative. And we can get that just from picking 2 points. We could actually calculate the slope, or we could just look at it and see that as t is increasing, the velocity is decreasing. So a of 4 is negative, since the slope of the velocity versus time graph at t equals 4 is negative. The last question asks about the average acceleration of the particle over the interval 2 to 4. Average acceleration we're going to find by getting the average rate of change. And as I've said previously, average rate of change we get by calculating slope. Now this does not mean that we take all the different slopes of the graph and add them together and divide by 3, although we can see that there are very clearly 3 constant slopes for the velocity versus time graph. Because it's giving us the interval 2 to 4, specifically want to calculate v of 4 minus v of 2 divided by the change in t, which is 4 minus 2. So v of 4 is 6 meters per second minus 9 meters per second divided by 2 seconds. So this results in 1.5 meters per second squared if we take the units and combine them here. Meters per second divided by second gives us meters per second squared. And that's going to do it for this problem.